line that needs those. And with that, I will turn it over to you, Dean. Go ahead and tell us a little bit about yourself, and the floor is yours, good sir.
Hey, thanks, Jason. Appreciate it. Hopefully it does have pertinence, because obviously if, the more insulation gets wet and there are more permeations in the building enclosure, obviously it's going to affect energy. But so I do think, if not directly related, I hope you find it interesting and maybe you'll take some nuggets away. Well, as Jason said, my name is Dean Kraft. I am a retired lieutenant colonel, 23 years in the Marine Corps, straight from high school to the Naval Academy, various different postings, all the way up for 12 years, major. Resigned from active duty in 2000, went reserves, and then the world changed literally 1 year later with 9/11. I was recalled for almost continuously 5 years straight from 04 to 09. In between, worked a couple of years for Trex composite wood decking, worked at ExxonMobil, and in the industry for concrete, moisture, roofing, and flooring, I've now been in. This is my, I guess, 13th year. You see a lot of letters after my name. I got a doctorate in 2017 in business, but my dissertation was on the whole process of evaluating concrete for moisture as it prepares for flooring. It was a longitudinal study of the literature. So some of this presentation will derive from that. I've presented well over 1,000 times. So a lot of my research was done because I ask a lot of questions. So if I was there in person with you guys and ladies, I'd be asking a lot of questions. I walk around a lot. I wear a Fitbit. I usually get a couple thousand steps during a 1 hour seminar because I'm always just active up there. The other part of the thing is you see some other letters, ASTM. I'm on the committee that ASTM D8 Roofing and Waterproofing Committee that writes the standards. I'm going to give you some information. This is 2020 information. Some of this information is December 2020 information when I talk about moisture testing, roof decks, things like that. This is very, very recent information. Jason mentioned AIA. If any of you do have an AIA number and need credit, you can always just put your number in the chat box, send it. We will self-report. We will take care of that for you. I just need to know your number and your name. If any engineers out there need PDH, there's my direct email right there. I can create a separate certificate that will say AIA, whatever it takes. Otherwise, Jason's got your reporting. One other thing before we kick it off, I got pretty thick skin. I don't mind being interrupted. So if something comes up that is counter to what you've been taught, believe, put it in the chat box. I don't mind. I will try to scan down and look at it, read it. I may address it right there. Same thing if I was in person. I welcome the interruption. I welcome the interaction. So just keep that in mind. And then lastly, there are some references at the end, so you can fact check or whatever. And then also too, if anybody decided they want a copy of the presentation, also please ask. I would make it available via PDF and via email. And again, you have my direct contact email right there on the right. So, when we talk about moisture and roof assemblies, we really want to kick off starting with one of the most common substrates for roofing systems, and that's concrete. And so these first 20, 25 minutes is going to be a lot about concrete because that's the substructure upon which a lot of roofing systems are built. And especially you get these large flat roofs, low slope roofs, that's what you're going to see, either maybe a steel vented deck or something, or you're going to have poured and pan concrete. So just to dispel any myths and to really kind of zero in on certain vocabulary, I just want to run through what concrete is, not to impugn anybody's intelligence, but what it is. And chemically speaking, concrete doesn't exist without Portland cement. That's the mainstay. And what you see across the bottom are the four major ingredients of what composes concrete. It is the most widely produced man-made building material on this planet, and concrete next to water is the most consumed material on this planet. So it's pretty ubiquitous, and our civilization is built upon it. Now, chemically speaking, when you take that Portland cement and sand and aggregate and water, admixtures and air and mix it all together, there's a chemical reaction. And that starts because of what Portland cement actually is. And if you look at the chemical composition, the major ingredients boil down to a reactive silicate, a dicalcium silicate and tricalcium silicate. And 75% of Portland cement is composed of those reactive ingredients, which is a completely side note, which is curious. On the flooring side, a number of people have tried to come out and say, things don't stick to silicate. Well, this is not silicon. This is not silicone. It's not silica, silicate. And again, it's one of those things where vocabulary, words mean something, and I'm going to kind of harp on that a couple times as we go this presentation. Probably 5 or 6 key vocabulary terms that are absolutely important, because if they're misused in conversation, the one person that does know what they mean, those terms mean, may go off on one tangent, where the one person that's using them kind of a catch-all, and you can actually not be understanding one another at all. But silicate, a reactive silicate. So that's really what Portland cement is. It's a reactive silicate and some other things. Now, most mixed designs, regardless of what the concrete is going to be used for, actually have 6 major components. Obviously, you have your Portland cement or cementitious material, maybe ash and slag, especially for like green projects, going for LEED, recycled content. Those are referred to as supplementary cementitious materials. You have your sand, your small aggregate. You have your aggregate, your large stone, the water, and then most every single mix you come across, either residential or especially commercial, it's going to have at least one admixture. And also, all concrete has some amount of air. Whether it's entrapped or entrained, intentional or unintentional, concrete is not a solid, completely solid, homogeneous product. If you did a cross-section of concrete, you're going to see some pore spaces, some capillaries. That's air inside there. So it's going to have some amount of air. But basically, all mixes boil down to these main 6 components. Now, admixtures. Remember, we're leading up to proactively addressing moisture in roof assemblies. And so part of that is making sure the roof assembly stays adhered. And since admixtures are almost ubiquitously present in all commercial roof decks, the best course of action is just assume that there are admixtures present. In most cases, and there probably are thousands of admixtures, in most cases, these aren't going to have any issue whatsoever. But there are some that have come up in discussion. Now, what I'm going to show you next comes straight from a technical bulletin from Carlisle Building Products, very, very well known in the roofing industry. And one of the major ones they talk about is a silicate-based admixture. And what did they determine? There should be no issue with adhesion. Why? Because Portland cement is silicate. So if you add an additional silicate admixture, there should be absolutely no issue with adhesion. Next, they talk about synthetic waxes or paraffins. These are sometimes used in waterproofing applications. They work great. They clog the capillaries and the pores with a wax or synthetic paraffin. However, as concrete is placed and water migrates to the surface, you may have a bleeding effect. And if any of that residual paraffin or wax comes to the surface, you may have an issue during a bond test at adhering. So it's kind of critical to know what the constituent components are of that admix in case there's a bond failure in the future and you're trying to triage what it is. And similarly with the wax or paraffin, silicone. Notice it's not silicate, silicone. And there's some admixes that may have a silicone in them, and they too could cause an issue with adhesion. Now, complete side note, and this is pertains really to my company, we fully disclose all the ingredients that's in our admixture. Not all companies do that. So if there were a case where there was a bond issue, if that company does not disclose, claiming some kind of trade secret, and there's a difficulty in gaining adhesion, it's very difficult then for the project team to determine why it's occurring if you don't know the ingredients. So just keep that in mind. Some admixtures may have surfactants or emulsifiers. Again, if those migrate to the surface, specifically those two things, and you're trying to use a water-based primer or water-based adhesive, and those go into a surfactant or an emulsifier, they may just not bond at all because the water's not going to work well. So just something to keep in mind. Now, when people talk about mix designs, when you look at a project, when you think about, a lot of people from a macro perspective may hear, oh, that's a 3,000 pound mix, or that's a 3,500 or 4,000, or that's a 3,500 lightweight. The next step they talk about, specifically, you might see it come up, is the water cement ratio, or water to CM, or cementitious material. That covers obviously a straight Portland mix, or a mix that might have ash and slag, ash or slag, or both, or whatever, is the water to cementitious material ratio. And what that is basically is you take the gallons of water, convert it to pounds, 8.35 pounds per gallon, and then divide it by the total pounds of cementitious material. So easy math, if you have a 5.0 WCM mix, you may have 300 pounds of water, 600 pounds of cement. That means, it's a 5.0 mix. Normally what you see, the lower that number, 4.5, 4.3, 4.2, 4.1, the stronger the mix is going to be, the higher PSI. Conversely, the higher the water cement ratio, 5.0, 5.2, 5.3, 5.4, the lower the strength is going to be. So just something to keep in mind. And so when we think about water, and you think about a truck on the road, you think about that drum maybe containing 10 yards, there easily could be 320 gallons or more of water that's in there. Why so much water? If moisture is an issue with keeping roof systems down, keeping the R value for insulation purposes, obviously moisture is for any building component, specifically in the envelope, can be deadly to any kind of product out, or any kind of building system there. So why so much water? Well, it's needed chemically. It's needed chemically for concrete to work. And this next section is going to delve into the processes within concrete and really try to codify and differentiate three terms that are routinely misused even in product literature. And the first one I'm going to start off with is hydration. Because for me, though it's chemistry and I'm not a chemist, it's the easiest to understand because it's so different than the other two terms, curing and drying, which are often used interchangeably. So hydration, what is that? Well, if you've ever used in anything you do a two-component something, and a lot of times maybe a two-component paint, oil-based paint, or a two-part epoxy, or a two-part adhesive. Sometimes you go to Home Depot, Lowe's, and you'll see some of the adhesive aisles where you have two chambers in a plunger, and as you push the plunger, it activates the two A and B meet at the end, and it activates and it causes a reaction, and that's how the adhesive begins its chemical reaction. Well, Portland cement and water are the exact same thing. Portland cement is the A component. The water is the B component. And what happens is those reactive silicates consume some of that water to create something different. They create a hydrate. That's why it's called hydration. They create calcium silicate hydrate. And that begins off as a gel, and it coats the sand, gets close, and surrounds the large aggregate, hardens, and that's what gives you the strength of concrete. Hydration, that is an exothermic, gives off heat, chemical reaction, whereby the reactive silicates consume water to create calcium silicate hydrate. The more efficient that occurs, the stronger, the denser, more durable concrete you're going to get. So that chemical equation is absolutely imperative for good quality concrete. And that process will consume about half of that water. So again, a lot of that water is necessary just for the chemical reaction. And then obviously, you think about concrete and all that extra sand and rock, and then we got to move it, we got to pump it, we got it to flow, to place it. Well, a lot of that water then is necessary for that process alone, but then most of that actually evaporates during time of placement. Now, this term is perhaps the most misused term as it relates to concrete. And again, if I was present, I would ask, hey, somebody, please show me, give me a show of hands. Have you ever heard, especially on the contractor side, have you ever been told that you can't proceed with having your roof installed until the concrete's fully cured? Or has anybody ever heard or said it takes concrete 28 days to cure? And I've actually seen that in product literature. Do not install until the concrete is cured, fully cured, for 28 days, or until it reaches its strength at day 28. Well, that's not what curing actually means. The exact definition for curing from ACI, American Concrete Institute, is right here. It's a process to keep moisture in the concrete. Why? Because of that slide right there. Concrete needs moisture. If it loses it too fast due to evaporation, especially in South Texas, well, you're going to have a problem with strength gain. You're going to have excessive warping, cracking, crazing, surface cracking on the concrete, losing too much moisture from the surface. Okay, so it needs it chemically. So curing really is just keeping that water in, so Mother Nature can't get it at time of placement. That's what curing is. And notice there's no real date associated with it. And in fact, when we're going to get to this first one talking about, you're going to see it's not even related to 28 days. All right. But again, this is what curing is. It's to prevent loss of moisture. And really, if you go into ACI 305, which is hot weather concreting, it'll talk about, it's not so much a time frame about how you cure or what steps you take at placement. It's really based on evaporation rate, which is a function of wind speed, solar radiation, ambient temp, ambient humidity. Obviously, the hotter, drier, windier, and sunnier, the faster you're going to need to do something to protect that slab. The colder, more overcast, drizzly at time of placement, you get all the time in the world. Okay, so the first method of curing we're talking about, the one on the left, and obviously they've already all been prepped, trialed, floated, and everything, is the one on the right there, is that waterproof sheet membrane. And that looks good for a slab on ground, but for an elevated slab, roof deck, may not work specifically with wind. But that's one of the ones right there, is the waterproof sheet method. Now, that one actually does have a date associated with it. And ACI says 3 to 7 days. Notice that's not 28 days. So again, curing in 28 days, curing is not about drying. Actually, curing is the reverse. Curing is about keeping moisture in. And it's not about 28 days. It's about until when it's complete. Now, the next one, curing compounds. These are actually often used on roof decks. Why? Because roof decks are often elevated, high above the ground, windy, and you're not really going to keep paper or plastic down up there. And there's two major ones you might come across. One is a cure and seal, which is often based on a silicate technology, which, going back to those admixture discussions, really shouldn't cause an adhesion issue. There could be issues with application, creating an issue with the bond, uplift issue with your roofing, if it's allowed to puddle during application. And so the application instructions need to be followed pretty closely. Separately, those are more permanent curing products. Then there's the self-dissipating ones. Also no issue. Most of these dissipate under UV degradation or foot traffic. But over time, they usually completely degrade. During a bond test, that may actually determine or may actually evidence whether or not it's fully dissipated. But one way to make sure they are gone is to go ahead and spec in that the surface of the concrete be lightly sanded to make sure it's fully removed. They're fairly easy to remove with a light sand. You don't want to use a chemical because any kind of chemical could cause an issue with future adhesives, but fairly easy to remove. And then I'm not even going to talk about the wet blanket water, the soaking blankets, because it's just not going to be used on a roof deck situation. So that's curing. Curing is not 28 days. Curing is actually the opposite of drying. Curing is keeping moisture in the concrete, preventing moisture from leaving. And it has nothing to do with 28 days. Drying is just what it says, just as we all understand it. And I'm not trying to be tongue-in-cheek with these pictures on the right, but it's something that we can grasp. We go outside, we hang up wet clothes, we come back later, they're dry, we take them off. Also, too, if it rains, they get wet, we gotta leave them back out longer. Or, you know, more new school, you go to the wash machine, you pull them out, they're wet, you throw them in the dryer, you pull them out, they're dry. It's a mass transport of water out of something, that water leaving something. It's due to evaporation, it's due to heat, it's allowing that moisture to get out. In drying, now we're starting to get more and more into the nuts and bolts here. Drying, a lot of these products, a lot of the roof systems that really have a relevance to what all you're concerned about, you know, for energy conservation, you know, getting the building closed in, all those products say the concrete must be dry. That's what dry means. The water has left. To a certain degree, the water has left. And because we're talking about, you know, the clothes on the line or the concrete exposed to the environment, it's a very slow weather dependent process. And again, if any of you in your history have had yourself or family members do clothes and hang them on the line, the higher the humidity and overcast, it's going to take longer. A good breeze, sunny and dry, it's going to dry fast. If it rains, it's weather dependent. Clock starts over again. Same thing applies to a concrete exposed roof deck. So that's really what drives the drying, not necessarily how much water was in the concrete to begin with. So how long will it take for that concrete to dry? More specifically, how long will it take after the concrete's placed before your project can start getting weather tight, can start putting that roof system on? This is a direct quote from ACI 302.2. Granted, it says for sensitive flooring materials, but it's about concrete. Notice the last bullet. It's the last wetting is what drives the time of drying. So if you have concrete out there and placed in Death Valley for 6 months, and then for whatever reason you get the 1 5-minute rain or dew every day, that slab is still going to be wet. So this is a very, very critical thing to keep in mind. Simply trying to engineer out the water is not going to address the issue of when you can put your roof down. It's whether or not you can control Mother Nature. It's the last wetting that's going to really drive it. Okay, so one specification idea, one design idea in planning, in schematic design, in project conception is to assume the concrete will have elevated levels of moisture at whatever point in the future your project is looking to install the roof. Why? Because you do not know when that last wetting will be, and the contractor cannot protect that concrete from getting re-wet. When I say re-wet, it doesn't have to be rain. It could be dew. So just keep that in mind. It's a very valid planning thought just to assume that the concrete will be quote unquote interior wet when it comes time for roofing. Now, so the 28 days, what we've shown is like it's not related to drying. It's not related to curing. So where does that 28 days come from? What is the significance of it? Okay, well, it's really associated on the concrete side with a desired design strength. So when the engineer says, 3,500 PSI, the rule of thumb is the expected design strength by day 28 from the concrete being placed. That's what it means. So it's really related to a compressive strength, not curing, and certainly not drying. That's what it's related to. Okay, and it's usually expressed within the project documents. Now, the concrete strength progresses over time. When the water first hits it, not much strength. Day 3 is coming up. Day 7, it's not unusual for projects we're involved with to see design strength by day 7. So what you have is you have an initial burst of strength gain, then you have a dormant period, then you have this long, slow strength gain over time. And in fact, concrete theoretically can get stronger throughout its life, so long as there's something to react with, the reactive silicates, silicon dioxide, and sufficient moisture and temperature. It will continue to get stronger literally throughout its life. And the way it's tested is ASTM C39. And the reason why I point out that particular standard is because of the time frames. Now, on this design strength thing, another design criteria that may be important is just to ensure that whatever the design strength specified for the roof deck is compatible, the minimum requirements for the material to be installed on top of it. In other words, you don't want to specify a 2,500 PSI roof deck slab if the minimum PSI requirement for the roof deck is 3,000. You definitely don't want to do that. So that's what I'm saying. You may sort of cross-reference that the required substrate for your Division 7 materials matches your Division 3 materials. This chart is exactly what ASTM C39 says. And you can see, you can start testing as early as day 20 or hour 24. It's absolutely not unusual to do compressive strengths at 3 days. So as you can see, it's not driven by 28 days. It's just the goal by day 28 to reach that design strength. And in fact, if it does not, say it's a 4,000 pound mix, but it's 3,800, the engineer may just say, well, let's give it another week or two, or let's go ahead and get the 56-day breaks and we'll give it to day 56 because we got plenty of time in the project. Or let's do a hammer rebound test or some other non-destructive test. So I just got to chat real quick. Somebody said lost audio.
Hammer, no, that's on their side, Dean.
Okay.
Hammer rebound test. That's one I haven't heard of.
Oh, hey, good thing. Hey, welcome back, Joseph. Yes, sir. A separate thing about concrete. There are a couple different ways, and you can Google this real quick. There's a couple ways to evaluate the strength of the concrete. They're called NDT, non-destructive test methods of in-place concrete. So rather than going out there and coring it and then doing C39 and compressive strength, there are different ways to do it on the job site. Now, this is not something the contractor can just arbitrarily decide, hey, this is what we're going to do. You obviously, please do not do that. You obviously have to make sure the engineer of record is on board with that method, but also for the code officials or whatever, there are absolutely different methods of non-destructive in-place testing for the concrete should there be an issue with the cylinders. Now, Jason, since you said something, remember that cylinder is usually representative of the cast-in-place concrete, but that cylinder is normally a 4-inch by 8-inch cylinder, and it can easily be compromised, not intentionally, but let's say the cylinders are cast. You guys get a little bit warm weather down where you guys are. Let's say they're left outside a little too long. Well, they're going to dry out. They're not going to have that moisture. They may be weaker than they're supposed to be. Let's say somebody didn't realize it and it got moved when it was too young and you got some micro fractures. That could affect the strength. So there are things that can happen to those cylinders where maybe you just had a bad cylinder. That's why usually the structural engineer doesn't get too wrapped up if they have a low break initially. Now, the problem then with coring and retesting is those microfractures. When you think about a coring machine, and if a core needs to be taken, it could also maybe cause an issue. A good question. Ling Yen Lu just asked, the design strength depends on the drying or curing. Not drying. Remember, drying is moisture leaving the concrete. Strength gain is indirectly related to curing. Correct. Because again, if you go back to the term hydration, hydration is the exothermic chemical process where Portland cement reactive silicates are consuming moisture. Curing is the process of keeping moisture in the concrete. So yes, strength gain is absolutely associated with effective curing methods, but it has nothing to do with drying. Drying is an evaporative process. Drying is like the red herring word. So good question. Curing is keeping moisture in so that concrete can consume, the cement can consume that water and gain strength to create calcium silicate hydrate. And by the way, the reason why it's called a hydrate, that particular word, is because water is chemically bound up in the equation. Calcium silicate hydrate is CSH, and that H is H2O. It is chemically bound. So that's really going to give you your strength, and it needs water to do so. But there are non-destructive methods to test for moisture. Yes, sir. Yes, most welcome. There are definitely some non-destructive methods that you can use. In all my time, I was actually involved with one project, casino hotel. No, it was Barrington Middle School. There was a question of the roof deck strength, and they did non-destructive methods, and they showed that there was just a problem with the cylinders because the results were so far off that didn't make sense, and they didn't want to core. Because even in coring, you can actually end up causing a microfracture in the cylinder. And so if you have a secondary or another failed break, it could be nothing more than just a compromised cylinder. So just keep that in mind. Now, that's concrete. There we are. Those terms are going to become important when you think about, trying to triage issues. So what moistures are we talking about? Okay, what moisture issues are we talking about to try to keep your roof system dry, be able to install it on time? And there are several. And this is not going to be all-inclusive. Obviously, there's installation of wet materials. I've heard plenty of stories where bundles of polyiso have shown up and there's moisture inside the bag from condensation. And nobody's taking the moisture content of the facer or the insulation itself. Is it too wet? Do we need to let it dry out before we install it? Obviously, projects in process, and maybe a freak storm comes in and wets the material that have been lifted to the roof deck. It doesn't include leaks and things like that. That's what we're talking about. What we're talking about is things that can be, again, proactively addressed. One of which is air leakage, one is air intrusion, and one is concrete moisture. These are all things that will lead to moisture gain within the completed roof system that could then compromise, obviously, R value, but could further compromise potential uplift and just the durability of the entire roof system. Okay, now these two I'm combining, but I can't stress enough the importance of really solidifying, no pun intended with the discussion of concrete, in your mind that the terms are different. Unfortunately, they're often used interchangeably. And the reason why it's so important to really brand in your head what the term means is because then you can pick the right way to ensure your project has addressed it. Okay, that's why I'm really going to stress these two different terms. And building science, all of y'all, especially in the spirit world, anybody that's involved with building science should realize that air has the potential to carry much more moisture than diffusion. So when we think about the amount of moisture that could theoretically pass through a concrete slab from the interior to the exterior, pales in comparison to the amount of moisture that could be transported through just a tiny hole or a crack in the concrete itself. Vapor can carry air can carry massive amounts of moisture as compared to diffusion itself. So controlling air obviously is critical, and that's we get the continuous building envelope. Putting the pen down and drawing all the way over. We have a continuous air barrier all the way around, sealed, no air in, no air out, or it's controlled. Now, these definitions derive from the NRCA, National Roofing Contractors Association, and the first term I want to go with is air leakage, and there's a definition. In it's not as clear as I would like because it talks about uncontrolled air movement in or out of a building. Well, theoretically, that could be air within the building controlled space going into an uncontrolled space, because that's it would be uncontrolled air movement. But really, it's easier to think of outside air getting in. So if you think about the roof membrane, we think about, well, a leak, a hole in the membrane itself, improper seals of the parapets or whatever, anything that allows outside air to get in. That would be leakage. Then you have air intrusion. This term is much, much, much better defined. And you can see it right there. It's the movement of conditioned indoor air into an unconditioned space. That's very clear. So if you think about a hospital, 10, 12-story hospital, and you think about stack effect, doors opening at the bottom and air rushing in, and that air moving up, 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 and if there's any unsealed penetrations, any unsealed cracks or whatever in the structural component of your roof system, that conditioned humidified air, cooler air, is going to be forced up into that unconditioned roof system, where it can then condense and lead to moisture gain. And where you guys are, your climate is more conducive to that material than drying out because you have more warm days than cool days. But the further north you go, you have more cooling days than warming days. And the more that occurs, you can actually have a net moisture gain over time, and you can saturate the roof system components simply through unsealed penetrations. And basically all those unsealed penetrations in the roof deck are like hoses for air to flow up and condense. So absolutely critical on the term air intrusion. Now, one of the reasons why clearly differentiating between these two terms is because how you address. Air is controlled, mitigated by air barriers. Well, the problem then is if people macroly, in a macro sense, in a project, start talking about an air barrier. Oh yeah, we got the air barrier. Well, which one are you talking about? Are you talking about the outside the building envelope, or are you talking about the one necessary to keep air intrusion from getting up into the roof deck? So in essence, there are two, because normally the exterior membrane in roof systems is also an air barrier. Now, going on with NRCA language, and that's where it starts getting confusing if you don't really start paying attention and asking the question. In 2001, this is a statement from NRCA. You know, they talk about proper placement of the air barrier within the roof assembly, but then they say leakage and intrusion. So they're separating those two terms out. So again, which barrier is being discussed? And that's the singular, the air barrier, as opposed to air barriers. And why it's important is how NRCA then further defines what a roof assembly is and what a roof system is. So you have air leakage, air intrusion, roof assembly, roof system. The roof assembly is the whole kit and caboodle, the structural element and everything up to the environment, the entire roof products. The roof system is just the roofing products, not the structural element. So when you talk about an air barrier where it goes in the roof system or the roof assembly, that really should be for air intrusion. The membrane itself is for air leakage, which would be part of the roof system. So the assembly itself should have an air barrier. And then obviously the membrane itself needs to be fully airtight. So there's actually two air barriers in a major aspect for specific low slope roofing applications. And again, regardless, all penetrations must be sealed for a air barrier to be effective. A side note, for air barriers and for moisture gain, another specification, another project consideration is to ensure, possibly accept that there will be some moisture gain. It's not going to be perfect. So be sure the materials installed up there have some degree of moisture sensitivity. Using a organic paper faced insulation material is probably not the best approach if you can go to a glass faced insulation. The organic is going to get saturated, may cause an issue with a loss of adhesion, breaking down. It also can promote mold growth. Whereas the glass faced papers insulation is much more resistant to any kind of net moisture gain or loss. So that's a side thing to keep in mind. Now, when it comes to air barriers, you know, you can go to the ABA or IBEC, and there's all these discussions of what makes an air barrier and what permeance value it needs to be. But let's be clear, steel is an air barrier as long as there's no penetrations. Also, concrete is an air barrier. So now, but to be effective, all penetrations must be sealed. So do you actually need an additional air barrier on top of the concrete against air intrusion? Technically speaking, no, you do not. But if all penetrations are not sealed, all cracks and joints and soil stacks and vents or whatever, if they're not sealed and insulated, then that steel and concrete are not actually acting as an air barrier. And that's one of the biggest things that leads to issues, moisture gain in roof systems, is that people think, well, we got steel and concrete up there, so we're good. But if you actually walk up there and take a detailed look, you start finding all these little penetrations, not sealed, not insulated, and they become basically hoses of humidified air coming up from the air intrusion and then condensing inside the roof system. Now, moisture and field testing, concrete roof deck moisture and field testing. This information right here is that information I said is 2020 information. Some of it is going to be as recent as December 2020. And this is a direct copy and paste from a research, that document right there, STP. This is an ASTM document. You can get it at astm.org. And so over the past couple of years, say I would guess 7 or 8 years, there's been more and more talk from the roofing side about the concern over concrete moisture in these low slope roofing systems. And, you know, if you read their image, it's not so different than their message. It's not so different than what the flooring industry has done over the past, say, 25 years messaging, you know, trying to point the finger at the concrete. But how does one then test? How does one test an exterior face concrete slab for moisture? This information right here was discussed just last month at D8. Currently, there is no accepted method for testing exterior concrete slabs for moisture. You have to grasp that. You have to accept it. Currently, there is no method. So you have to go back. No, I know. Because there are a ton of products out there that will say, oh, it must be 75%. There are articles from NRCA that said general rule of thumb is 75%. Just this year, they finally digested that there is no accepted test. Now, going back decades maybe, NRCA used to use the plastic sheet test. It hasn't been accepted for years. Now, on the flooring side, you have the calcium chloride test. However, and I'm on the ASTM flooring committee too. I'm on the committee that writes this standard. Didn't say I like it. I'm on the committee that writes it. But if you read the plain language of the ASTM, it says that exactly. How can you guarantee those conditions for an exterior slab for a full 48 hours prior to and through the conduct of the test? That test itself is a 4-day test. So you'd have to have a week straight of that kind of weather in those parameters for that test to be viable outside. Can't do it. It's not suitable, not acceptable for exterior concrete. Similarly, 2170, the RH test says the exact same thing. You can't do it. And in the webinar we had for the DA committee, that usually meets in December, this was finally digested. There is no, and then I basically came up to like, well, this is Moisture Task Force. We're supposed to be coming up a way to address this. And my comment was, well, I think the realization of the industry that there is no current test is an expression of addressing it. You need to message that. We need to let people know there is no way to test this.
Does this come, have you ever done expert litigation? It seems like I read that on your website. I mean, you would think that this would come out in a courtroom at how silly some of this stuff is.
I love that question. I actually did just this year. It was funny. I was just at a project meeting this past Monday in Lakeland. It was on the flooring side. And the flooring contractor and distributor were there, the GC, and our Admixtures is going into concrete, and we warrant against this issue. And we don't require any of these tests because our warranty is not based on this test. But it was interesting, and this is how it's messaged. The contractor said, well, the flooring manufacturer's warranty requires this testing. Well, I was sitting next to the project manager for the GC. I had the warranty for that flooring product pulled up. And I simply said, no, I understand. I said, but I find it curious because I have their warranty pulled up and I'm going to read, I quote, moisture not covered. I find it very curious that this project would be held accountable to chasing some test value over an issue, moisture, that manufacturer does not warrant. And then they stop talking. I mean, so when it's put on the table in front of them in black and white in their own language, they will concede. Otherwise, you'll keep being told that you have to test. But if you ask them, is there any accepted test for the exterior concrete, then they'll have to tell you, well, no, not really. There you go. And in fact, this document, this one right here on top, that was mainly written by members from SGH, a very large U.S. forensic engineering and consulting firm, Simpson, Coopers, and Hager. They were the authors of that document. So, yeah, if the insidious thing is, if you get a consultant that knows that all they talk about is the test and say you have to test, and then they quote the limits, you can get your what handed to you. If you have somebody like me on the other side saying, well, yes, I agree. That standard says that. But that standard also says it's not for outside use. That's the part you will find that the whole story, as you're now hearing, is not being told. You'll be told you have to test. You won't be told that the results are not warranted, nor are they even applicable to outside use. All right. So we already covered this right here, a last wetting. So I'm going to double down here that in the planning phase, either re-roofing or a new roof, the project should just assume that the concrete's wet. Why? Because ACI 302.2 for 15 years has said it's the last wetting and there's no way to test it. Okay? Now here, I guess, Jason, that was you making comments. This is where it gets a little bit more insidious. And that same document that talked about concrete moisture, this is a direct quote. Vapor retarders. If you want to control concrete moisture, use a vapor retarder on top of the concrete. NRCA has recommended this, and a lot of roofing manufacturers recommend this. All right? It is one of the main ways that the roofing industry is saying to address. Use a vapor retarder, and it even says, are a reliable solution to the problem of concrete roof decks causing issues. That's a direct quote from this new document just published in ASTM.
Got a bad feeling about this.
Okay. Well, yeah, because now you're jaded because you've heard me now for 30 minutes, 40 minutes. Okay, what it says is the same document says the manufacturer's telling you to use a vapor retarder. Don't tell you when you can safely apply it. Digest that. Use our product to control concrete moisture. Okay, when can I apply? How soon can I install it? Oh, we can't tell you that.
That's awesome. I
Why?
just love that.
This is another quote. Most manufacturers say the substrate should be dry, but they do not define what it means to be dry. And the stuff in parentheses there, in fact, what it means to dry is not defined anywhere by the roofing industry. That is my editorial. So the roofing industry says this material should be installed when the concrete is dry. Okay, what does that mean? We can't tell you. Well, how soon can I install your product? When the concrete's dry. Well, how do I measure that? Well, there's no way to measure it. What do I do about concrete moisture? Oh, do a vapor retarder. How soon can I install it? We can't tell you. See any issues in here? This is all black and white. I didn't write this. I wrote the presentation, but how is a project to know when they can install a vapor retarder? They can't. They can't. They also touch on these other issues too about workmanship, which I think are very important, and I'll speed up here. There's a lot of other issues they touch on too that you can have in your spec, okay? You can address, okay? Workmanship, primary application, surface texture. These are things you should be able to press your manufacturers to make sure is spelled out. It's not just enough to say that to install a vapor retarder, you also have to spell out the conditions. Moisture, for instance. In the roofing industry, in the D8 community, it says that these kind of products should not be installed if the temperature is below dew point. And in fact, a lot of products say 5 degrees above dew point Fahrenheit with the temperature rising. It's not enough to say, well, okay, it's 90 degrees out here. It's within the primary application directions. Okay, great. What's the temperature of the concrete? Concrete has great thermal properties. We placed a concrete slab at we did some tests on it, but it was my business partner's house in Mississippi. Over the course of 5 days, it never got hotter all day long than 93 degrees. By the end of that time, the surface of the concrete got to 130. What do you think a roof deck's getting to, especially in the environment you guys are in? So the primer can be installed maybe from 40 degrees to 100 degrees, but what if your roof deck is actually 130, 140 because it's been there in South Texas and absorbing solar radiation? It's got to be measured at the surface of the concrete, not ambient. Another one is substrate texture, called concrete surface profile. A lot of times, how the concrete roof deck is finished is not specified. Interior slabs usually have an FL value, have to be power troweled, smooth. Most low slope roofing components actually call for a smooth concrete surface, but they also don't define what that means. So if the concrete's if it's just floated and left the way it is, then it rains, you can have a concrete slab on the roof deck looking like that picture right there. And if you have a thin water-based adhesive, it's going to go down in all those valleys. Your peaks is where the membrane is going to touch. You've already reduced your effective adhesion area surface to surface probably by about 60%. So if you have a failure in bond, it's not because of moisture, though moisture could accumulate in those pockets due to dew or condensation. It's just because you did the wrong surface profile. And there's a variety of ones. On a scale of 1 to 10, this comes from the roofing and flooring industry, but it definitely applies to coatings. The thinner the coating, usually the smoother the profile. The less viscous, the less amount of adhesive, the smoother the profile. The thicker the coating, the more rough the profile to create a mechanical bond. And in fact, bond tests have shown, now this is one good thing from that document that I just showed you, bond tests have shown a very strong correlation to vapor retarder adhesion performance over long term. So bond tests are absolutely recommended. But don't test on a mock-up that's been power trialed and then try to install on your roof deck that hasn't been power troweled. Don't do that. Make sure, and that actually, the reason why I show that picture right there, that happened to a project we were involved with just north of you guys in Oklahoma. 30,000 square foot roof deck. The slab on the ground was the test slab. The mock-up for the roof installation was floated and power troweled. Smooth. Bond tests were fantastic. Every bond test on the roof failed. I'm like, this makes no sense. Thankfully, our rep out there was a concrete sub and a formal GC, and he goes, oh, by the way, as an afterthought, that concrete up there is really rough. I'm like, what are you talking about? Take a picture. So when they did a third iteration of bond test, we asked for some areas up on the roof deck to be ground smooth. They did it again. The base sheet shredded, couldn't get it off. The next comment from the GC to the concrete sub, grind the entire surface, 30,000 square feet. All because of the surface prep of the concrete initially at placement wasn't in line with what was going to be installed. Absolutely, absolutely important. On this, there are a couple test methods. Those documents right there both have test methods described. There's nothing really in codified yet in a specific ASTM, but there are absolute ways to test in-place vapor retarders specifically for bond tests, and they do show a strong correlation of success. Okay, so those are 3 areas about moisture. So what about concrete moisture? Remember, assume the moisture is there. Vapor retarders are a great way to protect against it, but how do you know when to install it? You're in a conundrum that you can never get out of. Oh, and there's no way to test other than possibly a bond test, but if the bond test fails, then you're stuck. One way is through the admixture in concrete. Now, selfishly, this is what we do, but they've been around for almost 30 years now. Close the capillaries down in the concrete to actually interdict that moisture from coming out. The use of our concrete, it's not unusual for projects to be able to proceed with roofing in as early as 8 to 10 days after the concrete was placed. And in fact, we just did a project in Portland with Firestone Building Products and Skanska. They did the bond test at day 8 on 8-day-old concrete. Exposed to the environment, 8-day-old concrete, bond tests were perfect. They did the lift over the weekend, and they started installing on day 11.
Wow. There's no way it didn't rain for 8 days straight in Portland.
Well, it's Portland. It's Portland. Maybe you guys down there, but it was Portland. And also this was the fall. So not only, Jason, not only rain, think about dew point, because that interior of the building was a little bit warmer. So it went through a dew process every single day. So if it actually didn't rain, that slab got wet every single day.
Every day, yeah.
But as soon as it was surface dry, they proceeded, they did the bond test, and they started installing on 11-day-old concrete, and all warranties conveyed. So I know that was a lot. I just got to 12:59. That's our summary.
I had you scheduled. I was thinking it was an hour and a half. So no, take your time, and I'm sure we're going to have some questions. So take
that's
your time.
Because I know I'm throwing a lot of you, and I appreciate your comments. And my apologies. I had an hour. I was actually cutting some slides out. Okay, so I will then elaborate then, and if you know, please.
That'd be great, because this is super interesting. This is the first. I had no idea. I knew so very little about concrete. I love the circular argument, the issue you're having there. I know I mixed 92 bags of 80-pound Quikrete myself, building my cantina bar during this COVID business.
that'll put some hair on your chest.
Good exercise. But no, take your time.
Okay, so okay, great. We got a Q&A there coming in. Oh, sure thing, Paul. Thank you so much. So I think I did the right thing. Open. Okay, there we go. Most welcome. Okay, so remember we started off with proactively address moisture in roof assemblies. If you're going to do that, it's not to say, hey, we're worried about moisture. You have to get very specific. You have to identify the source. Then you have to make sure you have a specific strategy that addresses each of those sources. You know that air transport a massive amounts of moisture. So you have to have an effective air barrier from outside air getting into your roof system. And perhaps even more important, you have to have an effective air barrier to prevent the air intrusion, the humidity, the conditioned air getting into your roof system. Steel and concrete absolutely block air. But if your air barrier, regardless of what the material does not have all penetration sealed and insulated, because then condensation can form anyway, then your chances of moisture gaining your roof system start going up. Now, concrete moisture. Concrete moisture is there. It's been a concern in the roof flooring industry for a quarter century, and it's really manifested itself this year, or the past decades, 8 years, in the roofing industry. The roofing industry has come out with two major ways to address some kind of vented roof system. Why a vented roof system? Because the vented roof system allows that wetting and drying, because it allows that airflow to keep moving in and out. It's incorporating a plenum kind of situation where if moisture gain does occur, if moisture gets in there through vapor, then it can go back out again through evaporation. It can get out. Obviously, if you have a very, very tight sealed exterior membrane for your roof, which is what you want, and you have penetrations, which is what you don't want, and your roof deck, you can have a constant moisture gain. And then if your roof system doesn't get hot enough, it can't dry back down into the interior. So that's why the vented. Or the vapor retarder. And then like Jason mentioned, this circular argument, and this really came out when I did my dissertation on the longitudinal study, because all I had been told is like, you got to test, you got to test, you got to test, you got to test. So I just kept working back in the literature, where this came from, who came up with this idea of required testing, and then kind of played it forward. And, okay, what does this process do for the owner? I mean, let's face it, all of us should be working to the owner's best interest. And there's actually nothing wrong with us serving our own best interest in support of the owner's best interest. There's nothing wrong with us being aligned. I mean, I can serve my best interest if it's done very, very aligned with what the owner wants. I can absolutely align that. But when I got to the warranties, and even the ability to what this other language says, then it starts breaking down. To add insult to injury, one of the documents I mentioned, ACI 302.2, that document that really codifies the requirement to moisture test, that document says that there's actually no correlation between the RH of the concrete and adhesion of resilient flooring.
No correlation?
Yes, sir.
Wow.
No correlation. There is no correlation. ACI 302.2, page 17, going on to page 18. There's no correlation. And I actually referenced that too. In my flooring presentation, I referenced that, and I pull that up. I'm like, there is no correlation. So now let's play this through. Most likely you cannot pass the test because of the low limits. You can't predict you'll pass because of rewetting in a project, whether it's a roof or an interior floor slab. You never know what's going to rewet your slab up to include dew point. All for a test that's not associated with adhesion, and not even warranted by the organizations telling you have to do the test.
What are your thoughts of a vapor barrier being required under a slab on grade?
Actually, on that one right there, I will tell you that there's that discussion is kind of going away. I know there's a lot of people talking about, doing the blotter layers to let it dry down. Otherwise, you're going to have excess curling, whatever. There's actually been a lot of research on that, and the idea that a slab or a vapor retarder is going to curl more is not proven out. It's not correct. What's really going to drive curling on a slab on ground on a vapor retarder, specifically in environments like that you guys and gals are in, is ACI 305. People not taking into account the evaporation rates. People not taking into account the ambient humidity, ambient temp, solar radiation and wind, and really being aggressive with a evaporation retarder. You know, Confilm was an old name. I can't remember. BSF got one. I can't remember the name of it. That literally, you know, after they're floating it, they're starting to spray this stuff on there. They even call it a finishing aid. Really getting on there early on. I think Ling asked earlier about, is curing related to strength gain? Yes, it is. But too often, the vapor retarder being on the bottom has been blamed for curling due to differential drying, when in fact, if ACI 305 was actually followed and not just the temperature, in other words, you could have quote unquote hot weather conditions based on evaporation rate at 60-degree ambient temperature. If you've got a very low humidity and wind and sun, your evaporation could be quite high. But a lot of times people say, well, it's only 80 degrees, so we're not in hot weather, so we don't have to worry about spending the money for the evaporation retarder, when they didn't actually do the calculation.
So, the city of Lubbock, that's where I went to college. The builders kind of run the show there as far as over the building inspection department. Well, it's super dry there and pretty warm there. And the builders have amended out the vapor barrier requirements. All of their new homes, slab on grade, I bet you, I mean, that water is leaving that concrete quickly. That's.
Well, if that's the case, then that actually goes against, I think, I'm pretty sure it goes against the new IBC, because I think the requirement for vapor retarder was actually incorporated in the International Building Code. Can you still see my screen?
Yes.
Do you see ASTM F710?
No, we're looking at the summary still.
Okay. I'm going to stop share, then I'm going to share again, and I'm going to change it to a different document. This is the document that is all, can you see an ASTM now?
We're seeing it. Mm-hmm.
Okay. This is the document, because you mentioned flooring. This is the document, again, I'm on this committee, that drives all flooring installation on concrete slabs, period. I don't care if it's residential, commercial, I don't care what it's for. This document is followed by basically every kind of flooring product out there, okay? And one of the things it states is paragraph 6.2. Vapor retarder is required. So in Lubbock, they should be aware that if any problem manifests with the flooring, the lack of a vapor retarder gives the flooring industry a 100% get out of jail free card.
Yeah.
So with me, what I'm going to do when I discuss and when I present, I always like to go to the literature to show people what the literature says. Mm-hmm. And so often people say, well, you said, I'm like, nope. I showed you what the literature says. And so that's a little different with me in presenting. I told you about my background and how long I've been doing this. But I still go to, this is the other document I wanted to show you, I mentioned.
Be placed directly on a vapor barrier?
Directly on it, yep.
Wow.
Concrete
the slab itself, not the flooring.
Correct.
Yeah, okay. I was like, well,
yeah.
How's that going to work? Okay.
Right. So now what do you see? Do you see the ACI document?
Yeah, the committee report, yes.
Yeah, read the top sentence right there.
The evidence presented suggests that there is no relationship between the relative humidity of a concrete base or screed and adhesion of resilient floor covering.
And the reason why it says base or screed is this was a UK, the Concrete Society is like the UK's version of ACI.
Okay.
Now read the next sentence.
When moisture criteria are often used, the relationship between these criteria and floor covering performance is not well understood.
There you go.
Wow.
And yet projects, well, the past 8 years, 7 years, roofing projects have been driven to try to pass these tests. And yet there's no correlation. But that's the ASTM world. That's what these documents say. So when I present, I try to specifically go to these documents and show actually what the literature says.
Mm-hmm.
And so the other thing too, I can tell you about the vapor retarder. A couple projects we're involved with since I've been doing this for 13 years. Of the, let's say, 5, documented failures, 4 of them were directly associated with an issue with the vapor retarder.
Really?
One in Oklahoma, slab on ground. I won't tell you the hospital because it's too close to you guys. Normal weight concrete placed on ground, elevated slab placed at the same time, same mix. Were both. The weather was extremely hot. I know you guys. It was the year you guys set a record for the most days above 100 degrees. So several years ago. I don't know.
1980.
It was another one. This was.
Yeah, about 6-7 years ago.
There you go.
Yeah,
That's it right there.
Yeah.
You had like 70, 80 days in a row.
Yep.
Something stupid. That's the year. Well, Oklahoma's not far away. They got hot too. And in fact, the first load of concrete had to get rejected because it flash set in the drum. And so I get called and say, hey, what's your admix? I'm like, well, first of all, chemically, it's not possible to do that. And I'm like, well, I know it's been hot out there. I get an immediate call back like, hey, listen, we found out that we didn't follow our own procedures. If we have 3 days in a row of 100 degrees, we're supposed to dump our silos and refill the aggregate, because if the aggregate gets hotter and hotter and hotter, heat is a catalyst to cause a flash set with concrete. So we worked through that. Well, this was a situation 7 or 8 years ago, 6 or 7 years ago. Well, the way we do it here is we put the vapor retarder and then we put a gravel base to provide a blotter layer. Well, that stone was hot. The stone was so hot that the concrete sub had to wet the rock to keep the bottom of the ready mix from flash setting. We had pictures of the guy with the hose, the vapor retarder underneath, wetting the rock to cool it. Well, where's that water going to go? Has the place to go. You've got a swimming pool liner underneath there. As the concrete's being placed, somebody was wetting the stone to cool the stone. Then they didn't follow ACI 305. They didn't cure the slab properly. The slab microfractured. They installed floor. Everything, same thing upstairs, same flooring. Upstairs never had an issue. The downstairs floor was basically a 100% failure. Another one, 30,000 square foot corporate aircraft hangar with a very expensive epoxy floor, homogeneous monolithic floor, no seams. Well, first of all, that's a problem. You're not supposed to carry epoxies across expansion joints. You're supposed to honor the joint all the way up. Obviously, there was an installation issue that didn't occur. Moisture issue. Well, we got pictures initially, and basically every 10, 15 feet in a straight line from side to side of the hangar, there was a ridge. Well, Mother Nature doesn't work in straight lines. So we're like, oh, there must be a joint there. Not only was there a joint, there was a moving joint. There was trash, there was all kinds of crap shoved in. They weren't even addressed properly. We cored down, no vapor retarder. It was completely gone. So there was a lot of things that could happen that with the vapor retarder could cause an issue. Because studies have shown over and over again that as soon as you place a concrete slab on the ground, you're going to reach at or near 100% humidity pretty quickly, because the water table, regardless of how deep it is, you're going to reach at or near 100% humidity below that concrete. Concrete's going to crack. Your protection against the moisture in the ground is that vapor retarder. Something else. Some of these products also claim they can protect against radon gas. So, yeah, if I'm building a building or building a house, I'm going to make sure it goes down. So that's just, and the literature supports that. Anybody
I
else
advised
has
them against that. I was like, I just think y'all are setting yourselves up for. Oh, they amended out the weep hole requirements and brick. I mean, I just think they're setting themselves up for litigation.
Well, now you know there's definite, and I'm almost positive, Jason, that it's in the IBC that a vapor recharger is required that meets the minimum permeance.
Oh no, it is required, but they just amended it out.
Right, but now they've also voided every single 09 flooring finish warranty as well.
Yeah.
They may not be aware of that. Or if it's residential, they may not care. They just got to survive a year and move on. I don't know. But
yeah, it's residential. They don't care.
Yeah. So that's just out there. I would always recommend. Ling asked the question, is microfracture or micro cracking the same thing? That's a good question. What I would say, when I use those words, what I refer to as microfracture, I am talking about something more through the depth of the concrete. Micro cracking crazing is usually a superficial, rapid evaporation of bleed water on the surface, causing those cracks, and those cracks don't usually extend the full depth of the concrete or anything. A microfracture, to me, penetrates. Micro cracking is a couple mils on the surface, unsightly, doesn't really affect the structural strength or anything like that. A microfracture is more at depth. It goes through it more. So when we're talking about compressive strength, if you had a microfracture through the depth of the concrete, or a majority of the depth, either horizontally or vertically, that could definitely affect the strength. Microcracking is normally surface. So not really meant to be splitting hairs, but I'm pretty sure that a fracture is more structural related. The cracking is more surface related, and because they wouldn't really call it a full depth crack. I know we think about, we see concrete crack, slab on the ground that's cracked, sidewalk is cracked, but a micro crack is usually surface crazing on the surface of the concrete. So, but again, this thing with roofing, and actually I know the construction industry has been led down a merry path for the past 5 or 6 years, requiring these moisture tests. I know some building products out there still require, or say, it's recommended to reach 75%, but it's been a big waste of time.
Yeah.
It's been a big waste of time and basically chasing. It's been a snipe hunt. There you go. It's been a snipe hunt.
Yeah, that's a good way to put it.
Yeah, it's been a snipe hunt. Excellent question. Eduardo just said, when contractors add water after the truck has arrived, will the strength of the concrete be compromised? I got 2 answers for that, Eduardo. And always, please, everybody listen very clearly. I defer to the structural engineers that go with what they say, okay? There's nothing against what's called holdback water. So I said, that one truck, let's say it's 320 gallons in 10 yards. So let's say it's 32 gallons per yard. Some environmental conditions, heat, transport distance, or whatever, it's better if the ready mix producer actually holds back a couple gallons of that mix. And I don't know what the percentage is. Let's just pick some numbers. Say they hold back 4 gallons per yard. So at the plant, when it leaves, they only add 28 gallons. So they haven't really met the mix design criteria. They're allowed to add that 4. And that's called holdback. And some engineers, some projects allow that, and they can add that to the mix on site, no compromise in strength, and it's perfectly acceptable so long as it's already approved by the structural engineer, not to exceed the quantities, blah, blah, blah. Do what the engineer says. So do what the engineer says, but that's one example where it could be absolutely possible to add water on site and people see the water being added, but actually, in actuality, nothing at all is wrong because all they're doing is getting up to where they didn't leave the plant that way.
And
Now,
it'll be job specific. And if you ask 3 different structural engineers, I bet you get 3 different answers.
correct. Absolutely. And so never, ever, ever, please take whatever happened on one job to the next job and say, well, the last job we could do this. And the person that would answer that question would be the structural engineer of record. But I'm just saying that, yes, it is a practice. It's accepted practice, and it's often done. Now, the question I think you're asking, though, is when water's added on site to, hey, give me some more slump. This mix is getting stiff. Can you freshen it up? Blah, 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 blah. That can absolutely, yeah, he just said yes. That can absolutely negatively impact the strength. And I kind of touched on this a little earlier with the water cement ratio. And what I said was a 5-0 mix is, say, 300 gallons of water and 600 pounds of cement. That gives you 5-0. Then as you go a lower number, say a 4.5, 4.2, that's less water, maybe 280 gallons per 600 pounds. If you go above that, 5.2, 5.3, 5.4, more water. Well, strength absolutely tracks, in many cases, that water cement ratio. In other words, usually the lower water cement ratio, the higher the strength. The higher the water cement ratio, the more water per pounds of cementitious material, the lower the strength. Now, within the 4.050 range, you could actually flip-flop a little bit because of consolidation. Remember, if it's too stiff, it's too thick, think about like biscuit batter. It's sticky and thick, then compared to like a pancake batter, which flows nice and smooth. If it's too thick and it doesn't get good incorporation, you may not get all the strength gain just because you don't have enough water. But as a rule of thumb, the more water, the less strength. Can then you add so much water on site that it then negatively impacts the strength? Absolutely. Yes, you can. Yes. I know I went around third base to answer that question, but I wanted to try to be fair and clear that there are absolutely accepted practices for adding water on site, and there's absolutely ways to do it that you're not supposed to do it. Yes,
No,
sir.
I thought that was a fantastic answer. I mean, that because I can just see as a, I joke that I'm a recovering building official, but you get out there on one job and you think, or, you hear from the structural engineer, it's okay. And then you carry that knowledge forward to other jobs. And ultimately, that the structural engineer of record is the answer there. Did you see Eddie's question that came in?
Yeah, I just see right now. How does over vibration of concrete of its place impact the potential for moisture infiltration? Well, it depends. I guess that's Eddie. I got to admit that's a new question I don't think I've ever gotten before. So I guess it depends. You're going to consolidate. Over vibration, as I'm thinking, and please chime in the chat if I'm not going down the right path here. So when you vibrate on site, specifically like a vibrating screed or whatever, I'm thinking slabs here. I'm not talking about the I'll be careful of the term I use, the wand type vibrators, specifically for like a lot of if you got a lot of rebar, you're doing like a parking deck, really thick concrete intersecting. You got to use the probes to really get down and maybe a finer aggregate. I'm thinking slabs. And so as you vibrate, the larger aggregate is going to settle. If you over vibrate, it's going to settle down further, more bleed water, more fines. I don't know. I guess I would have to take it a step further, is if they vibrate too much and then they actually induce some microfracturing as it starts to set up. But I would have to research that one. I would really have to research. I don't think I've ever been asked that question before. And I gave you my email up front. And if you would, consider emailing me, I would be happy to do some research on that. I just put it in the chat box too.
Awesome.
I'd be happy
and
to
I
research
send
that.
everyone, all attendees of the webinar today will get a copy of the PDF. So
Oh, that's right. You already asked me that question.
Yeah, so that you won't get bombarded. Well, actually, I'll probably be asking you more questions over the next year than anyone, just because I finally found a concrete expert. I've been looking for one for a while, so it's nice.
Well, here's my promise. If I can't answer it, then I will go to other people that I think that it can. I mean, we're part of ACI, we're part of Ohio Concrete, part of
Awesome.
Macapa. We're part of TACA right there. I mean, heck, you want a local expert, I can get you one. I'll give a shout out right now. Ken Vickers, Martin Marietta out of Dallas, Fort Worth area. He used to be at Argos. I think TACA's meeting this week down in down in San Antonio. So
that's me.
Yeah, that's you got a lot of good resources right there in Texas, but I can link you to people that are in Texas. And hell, Ken will give me a call. Yeah, Eddie just responded that over vibration generally brings a lot of moisture to the surface of the concrete. Okay, so now we're thinking the same thing. So what you're talking about then is that's actually that vibration is bringing that bleed water to the surface during the consolidation. In basically displacement, the more you vibrate, the more that large aggregate sinks. And like anything in any kind of fluid, which freshly placed concrete is a fluid. If something goes down, something else must come up. And so when you think about that matrix of the freshly wet placed concrete, as that stone goes down, something else has to go up. It has to displace something. And it's displacing those fines, that water. And what you're going to have then is more bleeding on the surface. So it will bring more moisture out early on. And if anything, depending on how that bleed water is addressed, it could cause issues leading to early cracking, microfracturing, just because too much water was forced out. Remember that concrete needs that water. So if you over vibrate, you could actually end up, I guess, squeezing too much water out of it early on. So yeah, that I would absolutely agree with. And then I think I know what you're talking about there. So yeah, it would cause issues. Okay. Yeah. All right, good. Yeah, Eddie. Yeah, that would, Eddie just said that's what he was thinking. Yeah, that would be absolutely be the case. Over vibrating would do that. And my concern then would be once the concrete does start to harden, you could have, Ling asked the question, microfracture, microcracking. If you squeeze too much water out of it early on, yeah, you could have literally where the concrete starts, pulling apart. Imagine like modeling clay, and you start to pull it and starts to create those cracks in it. You could have more full depth cracking that way, which is going to cause you certainly issues. Well, especially if you don't have a vapor retarder. So, again, I don't know if I qualify as a concrete expert, but I'm definitely humble enough to, if I don't know a question, I will reach out. I will find it. And as you can probably tell, I have no qualms with debunking some myths and showing you the literature from when I'm speaking, which I'm speaking. And I have no problem about using an industry or manufacturer's literature against them at all. And I'm like, you know what? You're talking out of both sides of your, well, we'll say mouth. You're talking out both sides of your mouth here. You're saying I have to do these tests, but you're saying that there are no tests that do that, and you don't warrant for that. So why are we having this discussion?
Yeah.
So, but I can tell you, if you use that on the screen right there, we've proceeded with bond tests as early as day 8. So we can address that. We can address whether or not you can move forward with installing your roof, specifically on a concrete roof deck. We can address that. There are ways. And it's unfortunate the way the industry's told you to do it just doesn't make sense. So.
Yeah. That was fantastic, Dean. Thanks for,
Oh.
I really appreciate you putting that on, and we are right on time. I'm glad it was an hour and a half, because that last half hour was of Q&A was fantastic. And I can't thank you enough.
Oh yeah, my pleasure. And again, anybody that needs AIA, come to me. Anybody that needs specific for PDH, please come to me. Be glad to help. Oh,
Yeah.
wow.
Yeah. No,
I just saw it from Peter. Holy cow.
and I tell you what, Dean, I've put on about 100 of these in the last year. So that's pretty high praise. Now granted, 30 or 40 of them were me giving the presentation, so that was a pretty low bar to get over. But I have had some experts on as well. So no, really a great job. I need to learn some more about concrete. That's what
Feel free, Peter. Thank you so much. I really appreciate that. I mean, I took a picture and showed my wife just so she can roll her eyes, because she doesn't think I'm all that in a bag of chips. But I really appreciate that comment. Thank you. And Eddie, again, you're welcome. Thank you so much for commenting. And I tell you, if you get a presenter that offers to, hey, ask questions, or if I ever present to your group again, do it. It really energizes me. And my gosh, you can imagine if I was there and when we had a happy hour, we'd be talking to freaking dinner. Because
I would love that. No,
once
we get out traveling again, I keep my contact information handy, and I'm sure you'll be in Central Texas. And if so, yeah. Or not only that, I'll let you know. I will keep that in the back of my mind as a potential for sure.
Well, also vice versa for your organization. If you guys have an in-person thing, it's funny. Armando asked me about roofing inspections. Armando, we don't actually inspect roofs. I did all this research. I joined the committee. I've got a draft installation for the roofing industry. I did it to combat the misinformation about moisture testing and the lack of very clear guidance on substrate surface profile that a concrete roof deck should be within the roofing manufacturers, and the importance of substrate temperature. So I am not a roofing consultant. I'm a manufacturer of the admixture. But I've always approached these things as if I am going to be, okay, hey, Gail, ex-roofer with, okay.
Yeah. I can tell you, I know a lot of the building inspection departments in Texas, and as far as a quality roof inspection, I would say maybe 10%, and then I would say 30 to 40% of jurisdictions in Texas typically don't do roof inspections.
Oh, okay. Well, I can tell you exactly. I told you that. Here's what happened on that Oklahoma job. I'm in Claremont, Florida. I get a meeting or invite to the concrete moisture roof deck issue, and I'm like, what? Oh, it's because of the bond test. And this is what initiated the project super, the roofing super, and the roofing manufacturer's rep were up there. They did the pool, and based on their quote, 40 plus years combined experience, that was a moisture issue. And that came up in the conversation starting off the presentation. And I said, all due respect, that's not going to work.
Right.
What does that roofing manufacturer say on how to install that product? Also, what test are you doing? And then when we grounded and it worked, my comment was, this is not a moisture issue. This is a slab surface profile issue. That type of roof product needs to be installed to a smooth surface, not one that looks like the dark side of the moon.
Yeah.
So compound what you're saying, Jason. Unfortunately, because there's not a concise document, which is what I tried to, it's in vote right now, and we're supposed to, it just got, we're resolving negatives, and it's called it's a standard guide for preparing a concrete roof deck to receive adhered roofing materials. And it's like a 5 or 6 page document that really captures a lot of what I said in this presentation, but I did it not necessarily to sell more of our admixture, but to try to debunk some of these things. Like, Peter says best presentation ever. And I really appreciate that, but because it's too difficult for any roof inspector to find this information.
Right. Oh, that's what I've found is just good luck. Well, not only that, a lot of times you can't get a copy of the standard for free. Well, there's not a building department in the state that has all of the standards, nor that even if they did have them, they don't have time to review that kind of literature. I mean, you have 25 inspections that day.
So both what you said, both of those things you said are absolutely correct. Very difficult to find the information specifically. Well, here's an exact example. I showed you in the presentation what SGH determined and wrote up this year. That the roofing industry is saying, use a vapor retarder to control concrete moisture. Try to get the information from them of when you can install it. It's not on their website. It's not in their installation instructions. Yeah. They don't tell you. But they will tell you, hey, use this product, use this product, use this product. Absolutely. That's the product we want you to use. Use that product. Okay, when can I install it? Crickets.
Yeah.
So not finding information should be pretty telling. And that, thankfully, I didn't write it, but that's what I was trying to get at through ASTM. I was saying, hey, where's the installation instructions? Where's the warranty for these products that says, yes, they can go down on wet concrete? Nobody answered me. Nobody answered me. So don't be surprised. It's a difficult thing to penetrate. And, the reason why we developed this presentation, as you notice, I mean, a lot of people don't even realize what I'm doing until the very last slides. Hey, by the way, we have this admixture. Yeah. Because the way we approach it is we don't feel that we can effectively give you a solution until you effectively understand the real nature of the problem.
Right.
And so that's how we approach it. That's how I approach my flooring presentation, the roofing presentation. We focus more on the problem and making sure everybody understands the problem. And like you said, the circular nature of this discussion, before we try to say, oh, by the way, there is a way you can move forward. We will do that. We can solve that so you can move forward. Otherwise, if you keep reading the literature, you can't get to A to B. You can't get from A to B. Can't get there. So,
yeah.
All right.
Okay. Awesome. Well, we'll wrap it up. Thanks again for joining us, everyone. Fantastic job, Dean. Really, I bet you this one gets plenty of views because it was dense enough that I need to go watch it again, and I'm sure other people will as well. Thanks for joining us, everyone. We have another one for you tomorrow, I believe. Well, y'all got the email invitation. We'll see you on the next one. Thanks, everybody. Thanks again, Dean.
Hey, thanks, Jason.
Bye, everybody.